Hey guys, today is the very first lesson of the year. We're going to be going over simplifying expression. So let's start off with what is an expression. So an expression is a mathematical phrase that may contain numbers, variables, and or operators. Remember, you have four main operators in mathematics, which is adding and subtracting. So I'm going to write that in. And something popped up. That might happen, sorry. Like adding and subtracting, you also have multiplying and dividing, but today we're going to be focusing on adding and subtracting. Um, a variable is just a letter. It's a letter that represents an unknown value. Terms are separated. So, let me so below right here where it says terms and coefficients, you have an example of terms. Terms are separated by plus and minus signs. Plus and minus signs. So here, if you look at it, you actually have two terms. Both of those terms are separated by that plus sign. Okay. Now the coefficient is the number in front of a variable. It has to be in front of a variable. It has to be in front of a letter in order for it to be a coefficient. Now, these are all terms that we have learned in the past year, most of you, if you took pre-algebra. So this should just be reviewed. Most of the things that we do here in the first 6 weeks are going to be review coefficient. Okay. Now we know that that letter is called a variable. It can be any other letter. It can be Y, X, Y, Z, anything like that. Okay. Now, when you have a term without any variables, or you have just a number by itself, that one's called your constant. Now, if you feel like I'm going too fast, you can always watch this all over again at home. Feel free to change the playback settings, slow it down, speed it up, whatever you would like. So this is term one and term two. Okay. Right here it says, based on the definitions above, complete the table for each expression below. So we want to know how many terms we have in this very first expression. I think I keep pressing buttons over there. Okay, we want to know how many terms we have in this very first expression. Well, we see a plus sign here, we see a minus, and it separates it into three different groups. Terms are going to be your groups of numbers or numbers with letters, right? So that means that we have three groups, three terms. One of the terms is 5x, 17 is also a term, and negative 11y, only because of that minus sign. Okay, you always have to make sure whenever you are separating your terms, you separate them including the sign in front, not the sign behind. You always want to include the sign in front of the term, not the sign behind. So if I'm separating this, I would separate it here. So you got 1, 2, 3 terms, okay? Variables, how many letters do we have in this expression? We have two variables, which would be x and y. Coefficients, remember, coefficients only apply to the numbers that are in front of a letter, in front of a variable. And in that case, we have 2. 5 is in front of a variable, negative 11 is in front of a variable. That minus sign is attached to that number, making it a negative number, okay? Constants is, remember, just a number by itself, no letters, nothing like that, just a regular integer, 17. Okay, so let's try the next one. This time, notice we have more plus and minus signs. So because we have more plus and minus signs, that means we're going to have more separation, more terms. So if you feel comfortable or if it helps you out, go ahead and separate those terms. Remember to include the sign in front, not the sign behind. Sign always goes in front, okay? So in this case, we separated it into 4 different groups, meaning there are 4 terms. One of those terms, negative 2.5y, negative 8, z, and 9. Okay. Variables, how many letters do we have? We still only have 2 variables in the whole expression. We have y and z. Coefficients, even though you only see one coefficient, you only see one number in front of a variable, there's actually 2 coefficients. Okay. Let me pause this video because I need to get something for all these pop-ups to quit popping up. It's gonna drive me crazy. Okay. So one of the coefficients that we have is negative 2.5. That one is clear as day right there. You can physically see it with your eyes. Now the other one, remember a coefficient is a number in front of a variable, is a number in front of a letter. Even though you're not able to see it, there is technically a number that's understood to be right there in front of the z. And those of you that had me last year should know this, number 1. So there is one of that letter, 1z. Okay. Constants, numbers that are without a variable. There's actually 2 this time. We have a negative 8 and we have a 9. Okay. Now, when it comes to simplifying an expression, we simplify an expression by combining like terms. But what is a like term? What can I combine? What can I not combine? Like terms have both the same variable. Remember, variable is another word for a letter. Okay, and it has the same power. Power is another word for an exponent. Get used to this vocabulary because they don't use letters and powers on the STAR test. They use variables and exponents, okay? So same variable, same exponent. So in this case, or in case you forgot what an exponent is, let me get my highlighter. I need a yellow one. My exponent is right here, that little 2. That is your exponent. That is your power, okay? So we're going to go through a few expressions, and you're going to tell me whether they are like or not alike or unlike terms. Can we combine them? Yes or no? So if we look here at the very first example, negative 3c, 5c squared. Think about the 2 rules. It has to have the same variable, same exponent. Does it have the same variable? Yes. Do they have the same exponent though? Well, I noticed that one of them has a 2, but the other one doesn't have an exponent. When you don't have an exponent that you can physically see, same thing. Just like a variable without a number, it is understood to be the number 1. So they do not have the same power, so these would be unlike terms. You would not be able to add or subtract these. Okay, they have different exponents. Different exponents, okay? The next one, 1/4 and 20. Well, these are both just numbers that do not have variables, so they are both considered constants. Even though one is a fraction and one is a whole number, you can think of that fraction as being what? 0.25. Can you add 20 and 0.25 or subtract them? Yes, they are like terms. Okay, they are both constants. Both are constants, okay? The next one, we have 8.5x and 8.5y. They both have an 8.5. So a lot of students tend to get mixed up here and think, yeah, we can add those because they both have an 8.5. But what is the rule? They have to have the same main rule number one, you have to have the same variable. Having the same variable means to have the same letter, and they do not. So these are not like terms. They are unlike. Okay. They have different variables. Okay. And then you have 100p and negative p. This one's a little tricky. Think about your rules. First rule, do they have the same variable? Do they have the same letter? Yes, they do. Do they have the same exponent? Well, because neither one of them have an exponent, technically the exponent is 1, making it same variable, same exponent. So yes, these are like terms. This would be the same as adding or subtracting 100p and negative 1p, because this one doesn't have, because this one right here, this term does not have a number. Remember, it is understood to have a 1 there. But because of that negative, it's a negative 1, okay? But they are like terms. They have the same variable. So, on to the mathematical part of this. Combining expression. So, before we actually start combining these like terms, there's one thing you need to understand is that we are simplifying expressions. We are not solving an equation yet. Solving equations comes in pretty soon, okay? It comes in a few days. But the difference between an expression and an equation is that an expression does not contain equal signs. Okay? An expression would be like 2x plus 3 versus, and an equation would be like 2x plus 3 equals 9. Equals 9. Okay. One of them is only going to get as small as 2x plus 3. The other one, you actually end up with an answer. And in this case, the answer would be 3, x equals 3. Okay. In an equation, you can actually solve for one whole number. In an expression, answers are going to be a little bit bigger. You're not going to solve for a single digit. So, however, expressions can be simplified. Think about whenever we were simplifying last year, we were simplifying fractions. We took a large fraction, made it smaller, but did we bring it down to a single digit? Not always. Okay. It's just reducing the amount of digits. Reduce. Okay. By combining like terms. Anytime you think of the word combine, anytime you think of the word combine, think add and subtract. We're not multiplying, we're not dividing. We're just adding and subtracting. Just adding and subtracting. And I promise that calculator over here on the side is actually going to come into play. So, okay, adding and subtracting. So we are going to combine the following like terms. When we first start combining or simplifying expressions, I like to combine like terms using shapes. Always put the boxes together, circles together. I like to draw shapes because it helps us differentiate, helps us be able to tell which ones I can combine, which ones I can't combine. So one rule of thumb that I told my students, that I tell all of my students is if it is a variable or if it has an X, draw a box around it. Okay, draw a box around your variables and draw a circle around just your constants, your numbers that are by themselves. Ooh, that's kind of ugly. Now, before you guys turn this into a hashtag, it actually stood for a number. So these are constants. Constants, okay? Let's start here with number one. Always start with the very first term. I'm going to draw a box around. This is technically 1x. Remember, if it doesn't have a number in front, you put a 1 in front of it, okay? The next term is negative 2x. That one also has an x, so that means I can combine. Can I combine the other two? No, they don't have x's on them. So when I combine these, we're typically used to seeing or used to adding and subtracting large numbers because you guys are so used to doing it by hand up until this point. When we add, like, let's say 23 plus 36, how do we do it? We do it vertically. 3 plus 6 is 9, 2 plus 3 is 5. Okay, so we're going to use the same concept here. We're going to write our 1x minus 2x below it. Okay, that still represents all of my x's, but one minus what you are actually going to combine, what you are actually going to do mathematically is the 1 minus 2. Now, a lot of students, whenever we get into using negatives, that's where we tend to struggle, or that's where we tend to make small mistakes. So we are going to avoid those small mistakes by putting it into our calculator, okay? And 1 minus 2 is negative 1, making this one negative 1x, okay? Now, you can also type it in as plus negative 2, but what you never, ever want to do is put a minus and a negative next to each other. Look at the difference over here in the calculator. Look at the difference in the answers. You're supposed to get a negative 1, but whenever you put a minus and a negative together, it gives you a big positive 3, okay? So just keep that in mind. You can put minus, you can put plus negative, but never a minus and a negative together. Next, this negative 3, that's a constant. I'm going to make sure, and I'm going to draw my circle all the way around, including the sign that is what? In front of it, not behind. And that 5 is positive. So when I write those vertically, negative 3 plus 5, I type it in exactly the way I wrote it down. Negative 3 plus 5, giving me a positive 2. So for the final answer, I put those together because this is a positive 2 right here. I connect it to the rest of my answer with a plus sign. Okay. Next one. Number 2. First number is a constant, so what do? Draw a circle around it. The next one has a variable, box, variable, box, constant, or number by itself without a variable, circle. So I'm going to do my letters over here, 2x minus 4x, and then on this side, 2 minus 3. Okay, 2 minus 4 is what you're actually going to type into the calculator. You do not type the letters into the calculator, at least not on the home screen. So 2 minus 4 or 2 plus negative 4, but never minus negative. That gives us negative 2x. Okay, then 2 minus 3, negative 1. Put it all together, negative 2x, negative 1. You don't need to put any plus signs here because you already have this minus sign or the negative connecting. The minus and the negative are similar. They do the same thing, but I say similar because they are still different. Okay, next one. Should pick a random color. Box, box, circle, circle, box. Now we have 3 x's. What's wrong with those 3 x's? Neither of those have a coefficient. We need a number in front of each one of these. Okay, so we are combining 1x plus 1x plus 1x. 1 plus 1 plus 1. Hopefully you don't have to do that in the calculator, but just in case. Negative 5, -1. Uh-oh, we have two negatives here. This is one that I can see a lot of students messing up. You could type it in as -5 minus 1, or you can type it in as -5 plus -1. Either way, it gives you the same answer. So that gives us -6. What do you not do? You never put a minus and a negative together. That's the difference between owing somebody $6, being in the negatives, and having $6 +6. Don't want to do that, okay? So 3x minus 6. Okay. Moving on. Oh, looks like we already used blue. Green, sure. All right. Circle, square, square. Uh-oh. Can I combine this n with these? No. Yes, correct. The answer is no. Because they are different variables, they are different letters, you cannot combine them. So I'm going to just draw another random shape, a triangle. And this one would be a circle. We're getting into some bigger expressions, so just be careful. All right, so we get 21r minus 4r. So what do I actually type in the calculator? 21 minus 4. Do we type the variable? No, we don't. 21 minus 4, 17r. On the other side, we write, what are my constants? 18 minus 3. Hopefully we don't need a calculator for that. Gives us 15. Now, because this one here is all by itself, that's going to be one that we just bring down. If it doesn't combine anything, that doesn't mean you don't use it. That does not mean it disappears. You still want to include it in the answer. So that 19n, just bring it down. And then my 15 is positive, so we connect it with a plus sign. Notice how large that answer is. Like I said before, when we are solving equations, you'll have a single digit answer, but with expressions, you can have, this is okay, you can have large expressions, okay? Another color, okay. Here we go, decimals. You guys hate decimals, but we got to get used to them because what? We're going to see them on the SAR test. Gonna see those on the SAR. This one does not have a letter. This one does have a variable. So let's combine 8.2j plus 4.7j. 8.2 plus 4.7, 12.9. Aren't y'all glad y'all get calculators this year? Makes things go a lot faster. But those of you that know me, remember, if you don't show your work, you don't get credit. You don't have to do the math in your head. Anymore. You don't have to tell me how, carry the one, do all that fun stuff anymore, but you do have to show me what you did to get your answer. Okay, so this one gives us 12.9j minus 1.7j. And even though I'm currently not here with you guys, just remember I'm coming back at the end of the 6 weeks. So be ready. Make sure you're showing your work. Go ahead and get used to that. All right. Draw a box. Oops, I was about to draw a box on that one. Am I supposed to draw a box on that one? Nope, because it is a different letter. So I'm gonna draw a circle on that one. Circle. Boxes for the A's. So 4., just 4a minus 2.1a. 4 minus 2.1 is 1.9a. And then when I get back, I'll have the calculator and the notes on separate screens. Usually, typically, I have the calculator on the projector and my notes on the TV. So it'll be a lot bigger. So I apologize if you're having to squint your eyes. 7.5 plus 9, 1.5b. Okay, now both of those numbers are positive. Right, simply writing 1.9a and 1.5b is not going to cut it. We need to be able to connect them. Now, because that 1.5 is positive, we connect it with a plus sign. Okay. Now, everybody's biggest enemy, fractions. Fractions. Here we go. How do we write fractions in the calculator? Now, I think the way I have it planned, I should be showing you that in a video before you start this lesson, but just in case, I'll show you again here how to do it in the calculator, okay? Now, this is just a number, no variables. 15 is also a number without variables. This fraction here has a variable, so we're gonna put a box around it. And this one is a constant, no variables, okay? So because there's only one box in the whole thing, we're gonna go ahead and bring down that box, 7 over 2x. But we do have to combine negative 4 and 1/2 plus 15 plus 23. Okay, now how do we write fractions in the calculator? There's two different ways. Because typically I would tell you always use alpha x, meaning the green button here with an x, which is right next to it, and you get your two little boxes. But because this is a mixed number, you want to use alpha y equals. When you use alpha y equals, you get a number of other options. Option 2 here lets you write in a mixed number. So I'm going to press the number 2. And that's where I'm going to put my negative 4, go to the side, half. Now, a lot of students will make the mistake and leave that little blinking arrow below the fraction. To complete the whole fraction, you have to move that arrow to the right. So I'm going to use my right button to move it over. Now I'm going to add my 15 and I'm going to add my 23. Oh, I put plus 23 and it should be what? There's a minus sign. I'm going to blame that one on pregnancy brain because I'm still, as I'm making these videos, I'm still pregnant. And if I'm breathing hard, it's because I can't breathe, guys. I'm struggling, sorry. All right, minus 23. There we go. That is the number I was looking for. Okay, so minus 25 over 2. Once again, our answers look kind of ugly, but it is what it is when it comes to simplifying expressions, okay? Next one, we just use that color. All right, we got a fraction, regular fraction, a number without a variable. We got a variable here, another g here, and another constant. So starting with our variables, we got 15 minus 11 over 8 g's minus 13g. Oh, that's a big one. All right, so 15 minus, that's just one fraction. It doesn't have, it's not a mixed number, so I'm going to use alpha x. 11 over 8. Don't forget to go to the side to complete that fraction, minus 13. Yes, you can put plus negative, but remember, never minus negative. That gives you 5 over 8g. And then on this side, move it over a little bit more. Maybe zoom out a little bit more. We're going to combine 3 over 8 plus 1 over 8. Now you guys are going to probably want to do this in your head. 3 over 8 plus 1 over 8 is 4 over 8. And what is 4 over 8? 4 over 8 simplifies to 1/2, okay? Oops. I understand if you guys want to do some of this in your head or do it by hand, because that's what you're used to doing, you can. But if I notice, especially when I get back, if I notice that all you're doing is everything by hand and making a lot of mistakes, we will have to address that, okay? Always, always for best, just to make sure, I would be putting it in the calculator, honestly. But you do what you have to do for now. All right, now, how would we see these types of problems in STAR test setting? Okay, look at number 9. Number 9 says simplify an expression for the perimeter of the rectangle. Well, perimeter is something that we go over a lot in 7th grade math, and we go over it a lot in pre-algebra. Here is one of our keywords. Anytime I see a keyword, I like to draw a box around it. We need to know what perimeter is in order to be able to solve this problem. To find the perimeter of something, what do? You add all sides. Okay, I'm gonna have a few people shout out multiply. Now, multiply is for what? Area. But also think about what we're doing in this lesson. We're adding and subtracting anyway. So we're gonna add all the sides. Now, the problem with this is we are missing some sides. But what do we know about rectangles? You have 2 pairs of congruent sides. So if the top measures 24.6x minus 10.4, the bottom is going to measure 24.6x minus 10.4. If the right side of the rectangle measures 7x plus 3.1, the left side is going to measure 7x plus 3.1. Now we can combine our like terms, and I'm actually going to write my perimeter down here. And we're going to skip the step where we do all of this math or writing it out just because we don't have space for it, okay? But we are going to combine our like terms. So what can we combine? Starting with our x's, we can combine 24.6x with obviously another one that looks exactly like it. But on the other sides, on the left and the right side, we have 7x. And we also have another 7x. Combine all the x's. So let's type that in. 24.6 plus 24.6 plus 7 plus 7. Yes, you could put plus 14 because I know I have some people are like, Miss, just put plus 14. And I'm thinking of names too. I'll tell you later. Okay. Then we do our constants. Negative 10.4, negative 10.4. You get that plus 3.1, plus 3.1. Now, how do we type this in? Because we are starting off with a negative. If you try to type in minus, notice how you'll have that A and S right there. Whenever you have this minus symbol in the very front, it is considered a negative, okay? Minus signs are for the middle of for being in the middle of 2 numbers. You only find minus signs in the middle of 2 numbers or in the middle of 2 terms, okay? If it's in the very, very front of the expression, if that's going to be the very first thing you type it in as a negative. So negative 10.4. The next one is in between. It's in the middle of the 10.4s, so minus 10.4. Once again, yes, you can put plus negative, okay? Plus 3.1, plus 3.1. And we get negative 14.6 or minus 14.6. And that is our perimeter. Ugly answer, it is what it is, okay? Number 10. Marge simplified the expression below as shown. What mistake did Marge make and what is the correct simplified version of the expression? Well, let's look at it. Remember, Marge didn't use an equal sign. Why did we not use an equal sign? Because we're not solving equations. Equal signs are for equations. It's in the word equal, okay? Equation. But take a look at it for a couple of seconds. What do you think she did? It looks to me like she just added everything. Yep, there's my 21 right there. So what's wrong with adding everything together? Well, let's solve it the way we would. If we were solving it the way we normally would, I would put a boxer on this one. I would put a boxer on this one. But I wouldn't put a boxer on this number. I'd put a circle. Why? Because it doesn't have that same variable. So they are not like terms. Because they are not like terms, what do? We just simply bring it down. Okay. So the only thing we're actually going to combine is that negative 8 plus 15, which is 7b. Anything that's by itself and cannot be combined with anything else, you bring it down. So this is the actual simplified expression. So what mistake did she make? She combined all like terms. So just be careful. Make sure you can combine what you're planning to combine. You cannot combine anything and everything. You cannot add and subtract everything. Okay. All right. If you are still a little confused and you want to watch the video again, remember, all of these videos are going to be up on YouTube. So just search for them. And that's it for this lesson.